Alrighty, good afternoon, and welcome to B-Sides Las Vegas, Common Ground track. This talk is from interview questions to cluster damage, adventures in K8's cluster shenanigans, by Amit Serpa and Travis Lowe. A few announcements before we begin. We'd like to thank our sponsors, especially Adobe and Aikido, and then also Formal and Drop Zone AI, as their support along with our other sponsors, donors, and volunteers that make this event possible. These talks are being streamed live, and as a courtesy to our speakers and audience, we ask that you check to make sure that your cell phones are set to silence. If you have a question, use that microphone just in the middle so YouTube can hear you. It's on and ready to go. As a reminder, the B-Sides LV photo policy prohibits taking pictures without the explicit permission of everyone in frame. These talks are being recorded and will be available on YouTube in the future. Feel free to move to the front so we can accommodate any more audience members. With that, let's get started. Please welcome Amit and Travis.
I think that's yours. All right. You have no idea how much appreciation I have for all 9 of you. 10 that came to our talk. So thank you so much for being here and for taking time to hear us rant. All right, let's begin. So welcome to our talk, from interview questions to cluster damage, adventures in Kubernetes cluster shenanigans. Next slide, let's go. So why are we here? You know, when we're talking about what the internet is like today, I always like to go back to the old adage that the internet is a series of tubes. I think it was said by a congressperson, and which explains a lot. But today, in today's world, when we're all doing cloud and magic and running things on other people's computers, when we come to think of it, everything eventually has Kubernetes behind it. So the internet is actually a series of cubes. There we go. Or the way that I like to call it, as a person who, and you'll soon learn about it, who does not come from a background of Kubernetes. Kubernetes is a series of YAML-induced headaches, and we're going to talk about that too. So,
So the origin of this talk is, turns out one day we were just sitting there talking about interviews that were upcoming and some questions that we wanted to ask the potential candidates. And it went from that's a good question to what would happen if? And that's how we ended up with this talk, is it was just a bunch of what would happen if? So if you came to this talk looking for like the coolest exploits or 0 days or anything along that nature, you're in the wrong room, because we're just going to be talking about what if scenarios within a cluster. So there's nothing exploity here.
yeah, so for the obligatory, who am I? So I'm Amit, I'm the guy with the weird name. So I work at CrowdStrike. I do security research, focused mainly on where Linux and cloud meet together, which is usually very shady places. I've been doing this thing for nearly, or over rather, 20 years now, which says a lot about my sad state of affair. And I'm actually not coming from the world of cloud computing and Kubernetes and all of that. I'm a low-level Linux guy. And I'm proud to say that Travis made me respect Kubernetes. These are my socials if you're interested. And yeah.
So I also do research. I've been in cybersecurity for about 15 years, but I came at it from the other angle. So when he's all the low-level Linux, that's not really my thing. I am much more at the higher cloudy level. It's more fun. It's more fun. But I also made this guy like YAML.
Lies.
It's true. It's true. Go for it.
Yeah, so I actually saw this meme not long ago, and I thought it's really appropriate for this talk, because, you know, I definitely need therapy, but this is my house, like this is in my home. This is my Kubernetes cluster. This is my big giant ass server in the basement that has 2 power supply units and is the sole reason of my very high electric bill. It's also a 15-year-old server I got off of eBay, so it's very, very inefficient. Yeah, so, you know, that's me.
Oh, skipping forward. I've embraced mini PCs, so I don't have the huge power bill. But I too also run a Kubernetes cluster at home because why wouldn't you?
And we're doing great, by the way.
Absolutely, yeah.
Thank you for asking.
Yeah.
Okay, so let's get a little more serious as much as we can. So why are we here? So Kubernetes is this over-engineered beast that has nothing to do with running at people's homes and running like 4 containers. It's completely stupid, but you know we did it anyways. But Kubernetes is, as I said, it's very complex. It has tons of components. It has the API server and the scheduler and the controller manager and like all of these things that are always making sure that all of the workloads on your cluster run. So it's constantly looking at what's going on your Kubernetes cluster. If a container crashes for some reason or a pod goes down, it will immediately self-heal and it'll fix itself. But because it's so complicated, it's also like security can be a pain in the ass when we're talking about Kubernetes because you have RBAC configs and you have like service accounts that you may have to make sure that they're configured correctly, and network policies, and and secrets management, which there's a cool demo over there. And there's like so many things that are happening all the time in your cluster, and it only means that there are so many things that can go wrong if you have like a wrong configuration or someone is doing naughty things inside your cluster. So we're going to talk a lot about that, but in order to like have a common ground, hardy har har, I'll let Travis introduce you to some basic terms in Kubernetes.
Yeah, so before we begin, I have a question for all of you. At all of my talks where I talk about Kubernetes, I always do a primer first just to make sure everyone's level set. Quick show of hands, who knows what a replica set is? Okay, it's getting more people, so we'll have to stop doing this soon. But so we're going to go through a quick primer. For you Star Trek fans, this is not a Death Star, which I've been told this kind of looks like. This is actually just paint primer. So here we go. So a quick overview. So Amit mentioned, there's the control plane. There's just all of these different components that are core components to it that help with all the automated things to make sure everything is at the state that you want. There's a lot that comes into it. So when you first install Kubernetes, there are like 66, I think, default primitives that exist within a cluster, and then you get to add more as you expand your capabilities. We're not going to talk about all of them. What we care about today is just a few things. So let's kind of break this down from the outside in. So on the upper right, we have an internet request that comes into a load balancer, and then it talks to a service within Kubernetes. That service is just an object that helps route traffic to the pods that exist. The whole thing that it does is make sure that it goes to the right pods because pods come and go. And a pod is like the lowest level of a Kubernetes compute that it manages. Anything below that is a container, which the container runtime handles, and containers get associated with pods via the kubelet and a few other things. A pod can exist inside a deployment, which is basically an organizational structure that says, I want 2 pods, 3 pods, 4 pods, and Kubernetes will go through and make sure that you've always got that state. If you just have a single pod running and it goes down, it's not going to come back. And that's what a deployment helps do, is make sure that it's being managed so that it comes back up again. All of these things exist within a namespace. You can think of a namespace as just like a big organizational unit that exists on the cluster. It doesn't actually exist anywhere in the cluster physically outside of where it gets stored into a database. It's just more of an abstracted organizational unit. A pod can actually have more than one container as well. Typically, you'll see a 1-to-1 ratio with a pod and a container, but depending on what's running on the underlying cluster, you may have like a networking sidecar for like Istio or something like that that's helping proxy traffic around the cluster. You may have security monitoring tools. You may have a logging capability. There's all kinds of different reasons why you might have more than one container in a pod, and that's just because they share similar Linux namespaces as they spin up. Back to that low-level Linux that I don't like. From the container runtime perspective, you'll have this orchestrator, this agent that exists on the node. And you can think of a node as an EC2 instance or a virtual machine or a physical server. That's all a node is. And it joins the cluster with the help of the kubelet, which is just a binary. It's like the agent for Kubernetes that runs on the cluster. And its whole thing, outside of making sure that the node is up and healthy and it's reporting home the way it's supposed to, is it talks to the container runtime to ensure that the containers that are supposed to be running on the node are actually running. I mentioned earlier that a namespace is kind of this weird abstraction for just an organizational unit. And this is what it looks like when you start scaling up a cluster to 2 nodes. So you'll have a namespace that kind of exists ephemerally across all of them. Same thing with the deployment. It's more of just a definition of how you want state to be. And then here, in this case, we have 2 pods on one node and 1 on the top node because we've defined that we want 3 replicas at any given time. So if one of them goes down, it'll spin up another one. It may or may not be on the same node. If the node goes down, Kubernetes will reschedule it and move it where it needs to go. Switching gears a bit, let's talk about service accounts in just kind of more of like an RBAC point of view. In Kubernetes, a service account is a who. A role is a what, and then you need a role binding that says these two go together. So if you're familiar with AWS, the role is basically like an IAM policy, and then the service account is just an entity, basically. But without all 3 of these working together, the service account is going to exist, but it's not going to be able to do anything. So when it needs to talk to the Kubernetes API, it's going to get access denied. Another primitive in Kubernetes is a secret. It's, in my opinion, a poorly named object in Kubernetes because it's not really a secret. Probably most of you noticed that the username and password there look very familiar, and they are base 64 encoded, and that's it.
Encrypted.
I'm sorry. Yes, you're right. Encrypted. So anyone who has access to the namespace and can read the secrets, or anyone who can just read secrets across the entire cluster, has access to these secrets. So a lot of times in mature organizations, you'll see vaulting get used. So like HashiCorp Vault or something like that instead of secrets. But in smaller organizations, secrets, unfortunately, they're misnamed, but they get used a lot for storing really sensitive information. And so here, we've got admin decoded and then whatever I picked for the password down there. As we talk about this YAML and break it down a little bit, we'll notice on line 5, the kind is secret, so that determines what the object is. So when you have a kind of pod, your YAML is going to be defining a pod, so on and so forth for all of those 66 primitives, plus whatever you add. The metadata, where it says name, my secret 2 is actually the name of the object. It's the friendly name that is going to appear when you're talking to the API server. And then on line 9, we have namespace is dev, which is commented out, but this secret would actually get deployed into that namespace. And so that's kind of like the typical schema that you'll see at a real high level within a Kubernetes cluster for all the YAMLs. Yeah. What is the type? So there are different types of secrets, and it just affects the behavior of it, basically. And so this is a config map. So a config map is something that you would see. Let's use the example of an Nginx or an Apache web server because that's what everyone runs when it comes to Kubernetes is web servers. A config map would basically have your web config. So if you consider what goes into config files typically, in this case we've got a game demo, it's the likelihood of having a secret in here or something very sensitive is pretty high as well. And again, this is just plain text, so anyone who has access and can read these config maps can see those things. That namespace organizational unit can be thought of as a really soft security boundary. And you'll see a lot of Kubernetes admins say team A has access to these 4 namespaces and team B has access to these other namespaces. And that's how they prevent people from cross-contaminating. But it is just reliant on Kubernetes RBAC. There is no other control that goes into place there. So you're basically 1 layer away from, oops. All right, your turn.
Yeah. So I forgot to mention, we're going to ask questions. We very much would like you to participate. There are very lucrative prizes right here. We worked very hard to source them. It was 2 separate Amazon orders. 1 arrived to my house, 1 arrived to Travis' house.
Transport them.
We had to transport them here.
Yep.
And yeah, so please participate when we ask questions, or else you won't get it, which is a shame, because we'll have to carry it back. Okay, so let's talk about Kubernetes security and visibility for a second, because it's kind of a big deal, and it's also kind of like complex. So, as I said in the beginning, I'm a low-level guy. I'm like an IDA guy. Let me reverse engineer things, binary patching, vulnerability research. That's my jam. And I wasn't really feeling the whole Kubernetes thing until I had this like sort of like a eureka moment. I was like, oh, wait, what if I will think of Kubernetes as a distributed operating system? Because like operating system, like low-level research of operating systems is kind of my jam. So what if I like just do like this sort of a head fake and look at Kubernetes as a distributed operating system? And at least for me, the moment I started to think and view Kubernetes like that, things started making more sense, for me at least. So as I said, Kubernetes has like tons of different objects and primitives, and all of these things work together. Even if you take Travis's example of like a cluster role and a cluster role binding and like all of these, it's like 3 different things that have to like connect together. So all of the like the visibility into these things can be like sort of cumbersome and difficult. There's also like the runtime side and the control plane side, which are supposedly connected, but they're not really, because when you are running a pod, this pod is running a container on an operating system, on a Linux machine, and it has all of the Linux machine stuff that comes with it. So you need to have visibility into what's happening on the runtime side, on like what the Linux machine is actually doing, which is like more of like an EDR-esque way of looking at things. But there's also everything that happens on the control plane. All of these objects that we've mentioned before that are interacting together, you know, millions of times per minute sometimes, depending on how big your cluster is. So think about how can you create a visibility for something, even if you're a security product, like how can you tie these 2 things together? And this is often not an easy task. Clusters can hold many secrets. And as Travis mentioned, secrets are not really secret unless you're working on making them secret, which adds even more complexity to things. And we'll, you know, there's a really cool demo that we're going to show you about that. Also think about the fact that clusters, they run a lot of workloads. They're connected to a lot of places, especially if you're like fully in the cloud and like things are connected to your VPCs and to your network. Sometimes even like a workload like, I don't know if you know it, WordPress, have you heard about it? Sometimes it gets vulnerabilities. And I mean, think if there's like a vulnerability in a WordPress or some other workload that you're running, and this pod happens to be connected to a whole bunch of other resources in your network. And again, it could be like a network in the cloud, like a VPC or like your organization. It can add like even more issues, and it can actually like pave the way for an attacker into your organization just by exploding like a shitty WordPress site. So all of these things, we need to keep them in mind when we're talking about visibility and monitoring. Another thing that I kind of like about attacking clusters is that old attacks are new again. So all of the stuff that we like massively scanning ports on a network, like, yeah, let's scan like a /16. So like it's relevant again within a huge Kubernetes cluster, because there is a lot of like sub-networking that happens inside a cluster. So suddenly old tools that we almost like forgot about them, or like things that are like, you know, just a gigantic nmap scan is like, yeah, okay, let's do that, or mass scan, like it's relevant again. And as I said in the beginning, like security products, a lot of them, they will tell you that they have good visibility. They'll tell you, we have complete visibility into your Kubernetes deployment. Many times they don't. Many times they will show you what they can. There are many different ways of collecting that data from a cluster. It's not always trivial to tie everything together. Again, as I said, you have the control plane, you have the data plane, or the runtime side of things. Tying these things it's kind of complicated. So once we have all of this information in mind, let's begin with why we're here for actually. So as Travis said, we're interviewing a lot at CrowdStrike. We're interviewing a lot of people, and there's a part of our interview that we do where we just ask like sort of like free form questions. So okay, we ask you like all of the knowledge questions that you should know or not, but then we're like, okay, let's play a game. How would you like completely fuck up a cluster? Like you have a working cluster and you want to do something really bad to it. How would you do that? And like, again, there are no wrong answers. I mean, there are, but like we mostly want to see like how you think. So this is the part where you can win a trophy and a medal. So we would appreciate participation. So let's say that you're an evil hacker and you have cluster access and sufficient privileges to the cluster, how would you keep the cluster from running and recovering broken or new pods? Now, why are we asking this question? Because if we are like role-playing of like role-playing in like this game where you're an attacker, when you want to see what's happening as a defender in Kubernetes, you might, as an admin, want to either exec into pods. So if you're not familiar, think of it as like SSHing into a Linux container, but you're not really SSHing into it. But that's basically, you're getting a shell on your container. So you'd like to, as an admin, you'd like to like exec into the pod and see what's running, or you would like to spin up a new pod or a new container with some security tools on it. And we, as the evil attacker, we want to keep these things from happening. So what would you do? So I would like to welcome you to a game of reverse DevOps Jenga. So it's basically like, what parts can we remove to get everything to fall down? Because in Jenga, it's the opposite. So I'd also like to talk to you a little bit about DNS in Kubernetes, because it's a complicated hate story. So Kubernetes has a thing that's called core DNS. And core DNS is everything that's in charge of DNS inside the cluster. Now, the thing about a Kubernetes cluster, which is kind of a cool feature, is that when you're inside the cluster, you can like everything. You can do everything with DNS. You don't need to know the IP address of a container or a pod. You can just address it by DNS. And also, the kubelet, the component that like talks to the API server, also uses that. So everything uses DNS in Kubernetes. So sort of like a single point of failure. So let's talk about a DNS resolution flow real quick. So a pod makes a DNS query. So for example, you have my service. The query goes to the core DNS pod. So what core DNS is just another container that runs in a different namespace, the kube system namespace, where all of the important Kubernetes stuff is. And it's just a pod that does DNS things. You would send a query, core DNS checks its internal records, and returns an IP address, like DNS. And all of that is happening in the context of an already running pod. So what happens if we take down DNS? So let's do it. The immediate impact, if we cause DNS inside a cluster to fail, would obviously be that new DNS queries from pods will fail. So if you have a workload that needs to resolve some host name, be it inside the cluster or outside of cluster, well, it's not going to work. Obviously, existing connections will remain unaffected, but eventually DNS resolution timeouts will occur, and new requests are going to fail, or they're going to take a lot of time until they time out, which is also kind of annoying. A default DNS query timeout in Kubernetes is about 5 seconds. So if things fail, things freeze for 5 seconds, which is a lot of time. And then it's like sort of like a cascade of failures that come after that, excuse me. Pods will eventually retry DNS queries based on their configuration, and configuration varies, obviously. But eventually, you'll start getting errors, and things will stop working. Obviously, some applications have some sort of like a DNS caching mechanism, but eventually things are going to fail. Like that's how it is. It's annoying, but it's not a complete disaster. So, for the first question, what if the admin wants to start a pod with a new container? So DNS is down right now, and an admin wants to start a pod with a new container. Who wants a trophy and a medal? Don't embarrass me. Yes. You mind using the mic? If we're embarrassing you, might as well like do it with a microphone.
Right here. Does it work though?
I think so.
Okay, good. So first of all, the container it needs to pull the container from somewhere. So it would address some service that will pull the container.
Okay.
And if it doesn't have, I don't know if it just knows what that service is or if it needs DNS to do that.
It needs
ready.
It needs DNS, and core DNS is down.
So what will happen is it will just fail and be in a loop until it starts?
Well, it's not the right answer, but you get you participated, so it counts. Yeah,
Get like a half
this
medal.
is yours. Another contender. Yeah, but I mean, it's sort of cheating, right? You want to use like kube control command to like spin up a new pod. So like, any guess? Will it work? Will it fail? That's cheating again. You get a trophy, though. Okay, we're gonna start running out of them. So, yeah, here's 4. Okay. Oh wow! Look at wow! Everybody wants a trophy. Yeah. You first. Sorry. Do you mind using the mic? I just can't hear you. And whoever's gonna be miserable enough to watch that video afterwards won't be able to hear you.
Yeah. So, if the admin wants to start a new container, no new pod.
Closer to the mic.
Sorry.
Yes.
Is it gonna be in a? It was more like a question. Is it gonna be in a like an inconsistent state where it can't obtain an IP address? No.
Sorry. Give this guy a trophy. Okay, last one and we'll move on.
I think you could be able to create the pod, but not the container, because you don't have the new address for the container to actually be built, I think.
Close, but no cigar. Okay, we'll continue. So the thing is that it's actually going to work. And the reason why it's actually going to work is that when you're pulling a new container, whoever is doing the DNS resolution is the kubelet that sits on the node. So it's using the DNS that's configured in like the, I don't know, like /etc/resolve.conf on that node. So it's not going through core DNS. So it's actually going to work, which is like, but wait a minute, I just took down core DNS. Like, why will it still work, right? It will work. You'll be able to pull a container. So the kubelet, as Travis mentioned, is just this binary, this agent, this Kubernetes agent that sits on the node and configures it and manages like DNS resolutions for inside and outside. It handles a whole bunch of things. It injects the cluster DNS settings. It does a whole bunch of things where it manages the cluster and everything about it. So, but when you are doing DNS resolution on behalf of the kubelet, when you're pulling a container, it will resolve through whatever DNS is configured on the host. But let's go back to breaking stuff. So let's continue talking about like a clustered denial of service. Let's break DNS. So again in the setting of an interview, this is like a cool answer we'd like to see. So a thing that's important to remember about DNS, about Kubernetes, sorry, it always tries to self-correct. So if something falls, it will make sure that, you know, a pod crashes, it will reschedule it and rerun it. If some service or deployment dies, it will again try to rerun it, because that gigantic list of objects that you saw earlier, they're all tied to each other. The API servers and all the core components are always trying to make sure that whatever it is that you defined in that horrible YAML, and YAMLs are terrible as like a broad statement, whatever you defined in your YAML should always work, no matter what fails. So we're basically trying to force things to fail. So what in that case we'd like to do is we'd like to patch the core DNS daemon set in Kubernetes to basically say, I am only going to provide DNS services for nodes that have a certain label to them. So a label is like a tag. You can tag things or label things. And you can actually run a command like that one here. I don't know if you can see I don't know if you can you see my pointer? No, you can't, because it's the other screen. Computers are hard. So if you run this command, what it's going to do, it's basically going to patch the core DNS daemon set and tell it, hey, if a node in your cluster doesn't have this label, in this example, I just call it like non-existent. So if that label isn't attached to a node, no DNS for you. So again, this is a feature of Kubernetes. we're not exploiting anything. There's not a vulnerability. It's just something that you can do. So in that case, you won't have DNS on your cluster. So at that point, we were like, yeah, that's how it works. That's how Kubernetes works. Sure, we're security researchers. We've been doing this for a while. We know what we're doing. And then we wanted to like model it in a lab environment so that we'll have a video and screenshots for this presentation. And then we realized that we're wrong and we don't know what we're talking about. Because even when we patched the daemon set, DNS kept working. And if before I had 3 core DNS pods running, I thought I killed all of them. I thought they're not gonna work. I always had one pod that was there and was still working, and I still had DNS even though I patched the daemon set. So why would you listen to me, right? So then we're like, okay, that is not enough. Patching and patching that label in is not enough. We actually need to do that, and we also need to edit the replica set of core DNS and make sure right here where that gigantic arrow is that we're scaling it down to 0. So now, even though things are supposed to work and spin back up, they're not going to spin back up. Again, feature. There's no black magic here. But imagine doing that. Sorry, and I'll just finish this sentence and continue. Imagine that you're a Kubernetes administrator or security guy, and you have to figure out why are things not working. And again, it's a million different objects. It's a million different things. What do you look at? Where do you begin? Is it maybe it's like something with the node is wrong, that it's not resolving things? Maybe it's something else. So this is why visibility into your Kubernetes cluster is super important, because if someone wants to like make you experience like a really bad day, or like he wants to cause you to have a bad time, it's fairly easy and straightforward, and it's like almost like part of the thing. So once we knock DNS down, a lot of other things are going to fail as well. So kubeproxy, which is the component that's in charge of managing all of the proxied connection in and out of your pods, that's gonna fail as well, because there's no DNS. It can't resolve the IP addresses to the pods that it needs to service. So now you have another thing that's falling down because a previous thing is falling down. So it's like Jenga when you're bad at it. So in this screenshot, you can see that me, as like an admin, I am trying to run a pod with the busybox image because I want to get a shell, right? And I just want to spin up this pod and do something, but things are not working. I'm getting like weird warnings. Like there's no DNS. I can't connect to anything. This hostname, Kubernetes Service Local, is actually the API server, the hostname of the API server from within the cluster. So that even is not resolving. So like you're going to have a really bad time. And trying to trace back what originated it and why things are not working, unless you have really good visibility, you're just going to have a bad time. So how do you prevent it? So just like everything with Kubernetes, proper RBAC hygiene. So make sure that only people that need to be a cluster admin or have the ability to affect things in the kube system namespace have them. Make sure you have some mutating webhooks that monitor critical components, and Travis will go into that as well. And obviously, good monitoring. And like just writing good monitoring here and just telling you to have it, it's like, you know, it's like, hey, it's your problem, it's not mine, right? But it's really, really important that even if you go and you go shopping for a security product, you need to make sure that it's really monitoring all the right things, or not whatever the vendor is trying to tell you that they're monitoring. You have to make sure that this is happening. You know, again, we work for a security vendor, and we're trying to, we're working on making sure that we have good monitoring. Okay. Travis Lowe.
Thank you. Okay, so this is a question for everyone here. Whoever gets to the mic first. Well, I'm only going to do one because we are ticking away at time here. If you wanted to exfil data from a cluster, how would you do it? You can get 2 trophies. It's okay.
Yeah, I'll try HTTP proxy, I guess. I
Okay,
don't
yeah, that's one way. Trophy.
Trophy. Another medal too?
Absolutely. Yeah, absolutely.
No, I'm not carrying that.
Yeah. So one of the things that we discussed during our setup was using webhooks. So Amit just mentioned mutating webhooks. Let's talk about what a webhook is, and then how you can use them for kind of like a persistent data exfil. During the admission process, when you submit your YAML to a Kubernetes API server, it goes through authentication, authorization, then it goes through any mutating admission. So it looks at that kind. So in the case of like a secret, it looks for the kind of secret, or a kind of pod, or whatever it is that it wants to mutate and change, and it'll apply a change to your YAML for you automatically behind the scenes, and you won't know it. This is really helpful in like Istio, so like a service mesh or something like that, or security tools. The admission control, the admins can basically say, hey, always apply a security tool to every new pod that comes into a cluster. That way your developers don't have to mess with it. They don't have to try to integrate with it. It just magically happens for them on the back end. It's really handy. It's really helpful. For an attacker, it's a really easy way to exfil data. What slide was I on? Moving on. Okay, so in our scenario here, we have a malicious webhook that's going to exfil data. So at point 1, you have your developer who makes a request to the Kubernetes control plane there in the center. We've got a rule, a validating webhook at the bottom that says, hey, validate all new secrets. Then step 3, we configure the validating webhook to kick all of that traffic to our helpful, handy, listening web server that the attacker controls. 4, the response comes back from the web server, and then it goes through the rest of the admissions process where it goes to step 5. Was it allowed? Was it not allowed? If it was, it gets written into the persistent data store for etcd, which is like the Kubernetes it's like the source of truth for Kubernetes. If it's denied, it goes the false path. Either way, it goes back to the user to let them know, hey, your workload was admitted, or no, it wasn't. This is what a validating webhook looks like. The only lines that we really care about today are the ones that are big and green. So we've got the URL of admission.jellyparks.com. So we have a listening web server at this external location. And then any new resource that gets, any new pod, config map, or secret that gets created on the cluster, the line right above where it says resources is operations, create, and update. So anytime a new workload gets admitted, anytime a new secret gets created, or anytime a new config map gets created, it's going to send all of the definition file to the admission.jellyparks.com. That way it can be validated, and then the response will come back. Is it allowed? Is it not allowed? So as an attacker, if you have sufficient privileges, you could create this webhook and let it sit there. Maybe people will know, maybe they won't. So let's go to a demo. Ooh, let's try the computer here. There's the mouse.
Hooray.
Hooray. Oh, this is going to be fun.
Space. Just hit space.
Yeah. No, I'm just going to have to highlight and talk at the same time. Is it going? It's not going. We got it. Go team. Okay, so right here we have our admission web server. Basically, we've got a /validate route where we're listening for post requests. And then we've got the UID, which is like the key for the request that we need to be able to return to Kubernetes. We're going to just print some things. If it's a secret, because that's what we care about right now, we're just going to print it to the terminal because this is just a demo. And then we're going to return, hey, it was allowed, a 200 with the UID. That's all we're going to do. So here we've got our Python server that we start. So now we're listening. On the next tab here, we've got a very similar definition that we just talked about, where we go to admission.jellyparks.com/validate. And then we've got the operation that we care about is create, as well as what resources we're monitoring for. This has already been applied to the cluster. So here in a second, we are going to delete a secret and then create one. So we're going to delete and create. Maybe. There we go. So it says it's been created. And then if we go back to our web server, we'll see that we've got the secret printed out as well as the data. So anytime a new object gets created in the cluster, it's just going to go. So it's a real sneaky-ish way to exfil data from a cluster. Bring the mouse back. Man, computers. So how do you stop this?
The thing is still visible.
Oh, the thing is still visible. Thank you. You questions?
I wanted to ask, will this also, like, is a secret created in the same way also when you create a pod with a service account?
Yeah, absolutely. So in this case, the webhook was looking for new pods. So any new pod definition that gets submitted, anything in that manifest would be exported out to our listening web server.
Yeah, but the manifest doesn't have the secret, but
Correct. Are
like
you
the
talking about the
secret just
service
gets
account
created.
token?
Yeah.
The service account token, no, that wouldn't be there because that gets mounted as a volume in the running pod once it
Okay.
spins up. Yeah, so that wouldn't be there. Okay.
But isn't it easier to just like run TCP dump or something like packet capture on all, like, start a pod with the capability to.
You could,
yeah.
if you had, access to the underlying node. You'll run into a lot of certificate problems, so you'd have to export all of those certificates so you could, unpack all the traffic and everything. So
You're also inside one specific node,
yeah,
right?
yeah,
You wanna look at everything
Yeah.
that happens all over the cluster.
yeah. So this would be cluster wide. So for TCP dump, yeah, you'd have to be in every single node.
Yeah.
So you could do it, absolutely. Yeah, it's another way. Yeah. So prevention around the webhook. Healthy RBAC is the key thing here. Do your webhooks change in your environment frequently? I'm guessing they don't. In most environments, they don't. So you could have a noisy detection to monitor any change to those, and then just ping your Kubernetes admins to say, hey, did you make this change? It's really easy win, and it gives you that extra layer beyond just relying on RBAC. And yes, cyclists do have to stop at stop sign. They're just like cars. Okay. So,
I would skip.
yeah, we're gonna skip this one. How would you enumerate a cluster? The anticipated answer is someone was going to say they were going to use mass scan or InMap or something along those lines, or use kubectl to interact with the API to say, show me all of the things. That is true. It's a way you could do it. But you can actually do it with as little as one API request. Kubernetes has a huge ecosystem, and Kubernetes admins, monitoring teams, networking teams, they install a lot of helpful applications so that they can monitor the health of the cluster. By default, a lot of them aren't necessarily the most secure. And so we're going to pick on one here called KubeCost, which is responsible for monitoring costs of workloads and tying it to a cost center, basically. All right. So we've got our Python application here. It's just going to make an API request on our behalf. So we're going to deploy it out to the cluster. And then we're going to let that go, and it's going to spin up. And it's going to be initializing here. Yep. Okay, so in here, we've got on line 12, the API for KubeCost. This isn't just any API. This is actually the Prometheus API endpoint, which monitoring teams use to monitor the health of applications. And then we are going to format through the data and print it out to the screen in a really handy, friendly way to us, basically. And we're just picking on KubeCost here. There are lots of other applications that have the same exact problem. Basically, what it comes down to is when you install a Helm chart, they don't put security around these endpoints because they just open it to the cluster. And so with one single API call to KubeCost, we have information about all of the load balancers. We have information about all of the nodes in the cluster. And we also have all of the pods and what containers are in them, as well as what namespace they're running in. From a forensics point of view, from a responder point of view, this is nearly invisible because we're not talking to the Kubernetes API. We're not making hundreds and millions of requests to the network to say what API endpoints exist here. We're making one API that blends in with normal traffic. Let's go back. For open ports, so KubeCost will happily tell you what services are running and where they're listening on. Other applications like Istio, they'll dump that information as well. Argo has all that information as well, and a lot of them have open Prometheus listening endpoints. The big fix here is network policies. You can think of a network policy as a firewall rule around your workloads. Most of the time, those aren't deployed by default in Helm charts because the application owners, the maintainers of those applications, they don't know your environment. They don't know what teams need access to the data. So they just leave it open and up to you, which is kind of like an ethos of Kubernetes is it's up to you to secure it. And so again here, it's up to you to secure it. You need to ask yourself, though, who manages those rules? Because it's a political battle inside your organization where no one wants to manage them. Okay, that was like a speed run of the last little bit there. Any questions while we have some time left? And then please remember, rate us 5 stars. Oh,
Okay.
stop. You'll have to come up here and ask us questions.
Thank you so much for taking the
Thank you.
time. Yeah.